Okay, we're gonna get started. Okay, firstly, we're gonna get started. We have a lot to go over. Since it's on Zoom, I might go a little faster. If you have any questions, just unmute yourself and then just ask the question. Otherwise, today's we're gonna go over this deck and then hopefully we can get to the next one. Okay, so we've covered a lot of different SQL queries, keywords, and function operations. There's a lot more. Obviously, for the length of this semester, we're nowhere near providing everything, and uh, it's not expected of you to know every single one of them. So there are a couple of my favorite places when I need to know whether or not a string operation, such as, concatenate or substring or convert or uppercase, lowercase, all these things, which we cover or we haven't covered. If you would just want to refresh yourself, or when you're coding, or when you're doing SQL querying, writing, and then you have doubts, please go to either W3 School, which is a very simple user interface, which I like going, or you could always check out on the specific um, database website. So if you're interested in MySQL, you can look on their documentation, or you can go to the TSQL on the left-hand side with the Microsoft. Those are just places as resource for you to remember. A few more that I need to cover before we kind of switch gear to a different topic of the day. Regular expressions. So maybe you heard of regular expressions in other programming courses, but it's these symbols within the ASCII characters. So on your keyboards, or when you press Shift and Control, etc., all these all combines. They made up some pattern to validate uh, strings, right? So, uh, especially when you're comparing or filtering a text, and then want to check if it's in certain pattern, certain symbol, that you can't easily use equal sign or any substring or these slightly simpler string operations, you can consider using regular expression. Now, regular expression is its own dictionary. So I would recommend, if you're interested, feel free to again go online to resource when you need to compare your uh, text with another character or pattern. Okay, so a frequently used regular expressions to validate values of email, because you oftentimes want to make sure there's an @ sign, and then there is a domain, and then there is a .com or .org, etc. So this is somewhere that oftenly use regular expression. Oh, concatenate, as I mentioned, is a pretty popular string operator. So you can, for example, if you have two columns, then one is first name, last name, you can concatenate them so that it will become full name. For example, number one, concact your first column, first name, and then you leave some space, adding a comma, and then last name. So what would happen here is for first name space last name after concatenations, okay? And the result here, John Doe, as you can see. Subquery in select. Okay, so with what we uh, with what we have gone so far, um, and especially we had touch up on in the keyword in last week, uh, where you are able to sort of gracefully use in a filter before select query, so that everything returned in the result column can be a candidate of what you're trying to match or filter with, right? So that after in, wherever comes the select statements after in that we talk about, that is a subquery of select statement. Okay, so we can also use subquery in subquery, such as this example here, in select clause. So as you can see here, we have a employee table here, and we use an uh, alias as E. So you can uh, have another column on the fly using a select statement here. And in this case, it's counting all the orders of a employee who has sold. Okay. So counting all the order a employee has sold, not just by one person, or it's all the sold order. Okay. So as you can see here, it's trying to match the employee ID from outside of this subquery with the filter in here at the where clause. So what it essentially have done here, okay, you can say that it's similar to have done a group by using a subquery here, and he essentially had done a group by statement. Okay, so it gets the employee ID, the first name of the employee, followed by the order number, amount of order that the employee has sold. Okay? And so normally you can also get it without a select query, select subquery here. If you just eliminate that, and then you will just put after from employee, you put group by employee ID, comma, first name, because you have to remember always including everything that you're balanced within select query and group by, as long as it's not aggregated value, right? So on the group by, you can have those two added, but at the select, make sure that you have the count star eventually as order sold. So that way, it will group by the order sold by employee ID, similar to this result. Okay, cast and convert, sometimes you want to convert numbers, or sometime you store a number in the string and you want to convert it back to integer, for example, you will use the cast or convert keywords here, right? So let's see the cast here. So the cast here shows that the price I only have previously stored as probably a long value or a double value. But I want to make sure that going forward, it's formatted so that it's only two decimal uh, after zero. So then that way, what we look at here is we have decimal 10 2, right? Meaning like in front of zero, it's all up to 10 digits. After zero, it's two. So use cast for that to make sure that going forward, it's only two decimal. You use convert when, as you can see here, 100 with a single quote means it used to be stored within text, right? So like a varchar or a character, such a data type, and you want to convert that so that going forward, when you're doing evaluation, it will be numeric. So you use convert. And then over here, it says amount signed. Okay, so as numeric amount. So it's going to be the numeric amount, and then it has signed. Normally this signed here, okay, uh, actually it's not a very quite common type. So I would just say, you know, stick with something that you know, such as integers, or um, I don't know, decimal, if you want to make sure that it's stored in a numeric way for price or amount. Substring, the word substring shouldn't be foreign to you, shouldn't be a stranger. So basically, it's taking out partial uh, of the string that your original text has, right? So for example, let's say the text is stored as a product name, and then you want to have the index one, meaning position number two, right? So because position number one is index zero, right? So starting from position number two to position number four. So you just want two to four. All right, just two characters. Okay. And then the substring will just basically cut the 2 to 4 and then store it as short name. Here's how you would do upper case or lowercase. I think we cover like a couple of times. Remember using like followed by underscore or followed by ampersand. Okay, so I'll let you guys review that. We've gone over this before. You can also use regular expression. That again, regular expression, the way that you will state that, you don't use any um, equal sign or like sign. You just do a column after where you do a column and then immediately followed by regit and the pattern that you are expecting to validate. Okay, still yet a lot of them we didn't cover. Again, go back to I would say W through school or go back to the link that I showed earlier if you're interested, or when you're doing some querying and then you're having doubts and wondering if a certain keyword exists, those are best place. All right, we actually gone over a couple of schema in addition to table, and we're going to come back and then kind of dive in a little bit. So, another schema type that we have mentioned before, in addition to table, is the view. Okay, so in here, the definition cannot be more accurate. So, a view is a virtual schema. Virtually it looks and created just almost identical to a table. Okay, but the way that it's being created is based on a result set of a select statement. Okay, so really quick jump to the create view syntax over here. Look, so you will create view, okay, and then give the name of the view, and then skipping the parameter for a second, parentheses for a second, and then you look at bottom, it's a select query, right? And then it's similar to just normal day-to-day select query over here. But in front of it, you have a create view with the name. So, for example, that select query could be select star from student inner join blah blah, as long as the select query runs and closed up with semicolon like usual. If you put a create view and then give a name of the view, it will basically store the select query as a schema that doesn't take up any extra space, but is store sort of this query into a permanent a permanent structure so that if you are calling this view and then the way you would be calling this view will just be like a table, you can do select star from this view. It would have already memorized that you are trying to pull the result from your select statement that you previously defined this view on. Okay? So a view will always shows up to date. Okay, so every time, because it doesn't store the data actually, it doesn't actually embrace and it doesn't actually store the data within view, not like tables, so that every time it's being called, it's always going to run the select query over again, right? And so in that case, when you're getting it, you don't have to worry that it has an outdated data from the last time this table that you query. Like if there was any update on the fundamental table, right, underlying tables or tables, then it would be reflected on the view because it reflected on the select query. All right. Okay, so some of the benefit as we sum up the view is you don't have to redo all this joining and very long select query. Um, it would query the latest with including the updates, okay, before it returns the result. It stores the select query for you in a very nice, neat way. it queries almost, you can query it almost like it's a normal table because fundamentally it is a schema, but it's different from a table, right? It doesn't actually store the data, but it would almost as like the select query result, almost like its own new table. So it looks as the data were coming from the view, but it's actually pulling from the single, the front line, underlying tables. Okay. I think the update replaces underlying table here, just not to confuse you, just mean that if you decided to keep the same name of the view, but you want to have it attached to a different select result set, you're ha more than welcome to do that, right? You can, over here, as you can see, you can either do a re create or you can replace, okay? Query caching. So some databases has a way to smartly cache, as we mentioned, that it always get the newest data, but some query would have a way to smartly keep some of the old data as long as it's still accurate. It might keep it there in the memory so that it doesn't need to pull the entire disk to get some data that they had previously returned before, even though it's going to still look for the delta, meaning the updates on your underlying table to get you the accurate data eventually. But they have some smart caching mechanism in to store in the memory all data that previously this view had been called for. So in that case, it would help making querying the view much faster. Okay, getting the result much faster. Okay, another schema that I have brought up. So the first one table, second one view, the third one is temp table, right? So a temp table are actually quite common, but there's two of its uh, instances that you see that often on. One is that you actually, within a stored procedure or within a function, which we might cover today or next session, that you see it actually being instantiated or it actually initiating a temp table. And that temp table may be anything from declaring at and then give a name equal to something. So the at is almost like if you're familiar with JavaScript, it's almost like var and then the name of the variable, and then you assign that to some value. When you do an at sign and then you give the name, it's similar to that. So you're assigning basically a table to this local variables, right? And so that at sign became if you assign it to a table, then that at whatever name became a temporary table. And another time is just what we had discovered. We just mentioned about the subquery, right? So this select count star from orders O, right? This over here essentially returns you a select statement. And then here you can basically think of it's a select statement within select statement. So this essentially create also a temporary table that after this round of select count is used, it's being disposed. Okay, so this is another less of an obvious temporary table. But either way, the temporary table commonly are used because you need to have just a temporary place to store the table for an inner loop or just a function within a function. It automatically drops when the function or the sessions terminates. All right. Now, those are some, we covered string operations. We just went over also, just dive in on some of the things that we cover on schema. We are going to re-review and dive into constraints. Okay. Now, SQL constraint. Obviously, those constraints obviously would brought back primary keys and foreign keys, right? As I mentioned, let's refresh our memory a little bit. A table are schema that we use to store data in relational database, right? Now, a simple newly created table without primary keys, forget about normalization, without any type of keys can exist, right? As long as it's not, as long as it's provisioned within the definitions of runtime uh, and just some SQL rules, it does exist. Now, you may add a new column called IDs to it, right? And that ID maybe is where you unofficially want to keep the unique number to identify uh, each instance, each rows, right? The identity of each row. Now, up so far, it's great. And then you can have multiple of those tables, right? Those, fine. You can do that. Now, you can start thinking about making them, making these unique ID, right, more useful. And also with these tables that you created, as it grow bigger, you may want to have certain automatic uh, error checked, for the lack of better words, for you uh, that was ready to use outside the box of relational database, right? And as I mentioned, if you remember, when you want these benefits, it comes with constraints, right? So first things first, if you want to make your ID, if you want to make a column, right? You don't have to. But if you want to make a bona fide primary key on a column, right? Then great. This means that this column, once you make it a primary key of the table, that means that it would absolutely be unique because the SQL database is going to make sure that if you have duplicate number, it will not be allowed, right? So great, you get that for free. Also, it would absolutely not allowed to be null, right? We also remember that. So database will also check for that. So on the hindsight, you get those automatically checked for you, arrow checked for you, but it is also the constraint. Now you need to make sure that it is always unique. And maybe that's how you always want it. So there is this very good balance, and you must understand when you have these constraints, right? The table doesn't necessarily immediately have primary key constraint. But if you look at these constraints and then decide to add these keys onto it, whether it's for normalizing, whether it's for building relationships so that you can have foreign keys and all that, or maybe you just want to use the database to arrow check some of these provision for you so that you would be more secure when you are normalizing or when you are trying to follow the ACID property of the relational database, right? So now we talk about primary key constraint, as I mentioned. Must be unique, must not be null. Okay? You can only have one primary keys per table. Okay? Now, the other table that you want to associate with your first table, you might want to make foreign keys on it, right? The constraint of that foreign keys is what we have mentioned before of referential integrity, right? And that referential integrity tells us that it, when you're inserting a new row that has foreign keys on it, that foreign keys value, that foreign keys value must have already existed in your parent table, meaning that primary keys have to already exist, right? That is the first and foremost referential integrity, right? Now, to add more extension to that referential integrity, there's also some rules or some actions by default that the relational database will take place in order to prevent broken relationships. So what are some of the example I can make a broken relationship? So, for example, when I make a order on Amazon, right? I'm the customer and I made an order. So I'm the customer, I made an order. So order can have a order can have one customer and one customer and a customer can have many order, right? Let's say that order cannot be purchased or not a group can place the order for now. So only one person can go and purchase and pay for a shopping cart on Amazon. That's assuming that. So it's a one-to-many relationship, right? And so let's say on the order table, it would have me as a customer ID on there as a foreign key. And on the customer table, we'll have a primary key that's customer ID that has my information on, right? And the extensions of referential integrity here after the insert is that what if today someone or some reason there is some type of programming event that is about to delete me from the customer table, right? Whether it's by accident or it's intentional, want to remove my entity from the customer table or remove the role that has my customer ID from the table. After that, I have already placed this order, meaning that the order ID, order table already have orders that has the foreign keys of my customer ID. That is what we're going to discover. These referential integrity, in addition to inserting into, what are some of the other referential integrity that is in place to prevent breaking these type of relationship as I mentioned? Okay, first of all, as I mentioned, the example that I have, after a customer places an order and say that it's a one-to-many relationship, the customer table has the primary key, the order table has a foreign keys. When someone is trying to delete the order table, let's take the easy one out of the picture. If you are removing my order from the customer table, assuming that the relationship that we're talking about here, that we're focusing on, is just this one-to-many customer ID, right? That would be okay because you're deleting a referencing table, right? It's the child table, right? It would not have a broken relationship. The customer ID of mine will still exist on customer table. Now, you may ask me, well, but you're deleting some log or reports or history of order. Yes, so that is a separate question for the business, right? Do you want to remove those transactions? Do you want to remove the record? That is up to the business or the company to decide, or whoever managing the database to decide. That is a separate business logic. But what database will be deciding is focusing more on what would happen if the primary keys is being deleted. In this case, by default, most of the database, including MySQL, by default, it would throw an error restricting you and letting you know that this action will be deleted, it will be restricted. No action can be made. Meaning that when you're trying to delete a a customer's role who already placed an order, meaning that that foreign keys already exist in the order table, that would have broken the foreign integrity, referential integrity, according to relational database. So by default, it would be restricted, meaning nothing will happen. you're likely going to get a very generic error message such as primary key uh, is there's a foreign keys or there's a referential reference. So no action has been made. Nothing has changed. Now, if you were to want to enforce that this is intentional and you are absolutely sure and you want to change this behavior by default, you can change it so that look at the bottom line, bottom here. You can go and alternate the table and add the foreign key or update the foreign keys referencing this original table, and then provided the type of actions you want it to be instead of no action by saying on delete blah 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 on delete blank. Now, two options, most common two option here on delete is cascade and set null. What does that mean? That means if you say cascade, that means the child foreign key is going to be deleted along with the entire row of that key. Okay? Cascade means that it's going to follow the same action as its primary keys row did. So if you're deleting the row of your foreign key, then on delete cascade will also delete the row that has all the foreign keys of that primary key row. So has all the foreign key, all the order, for example, in this case of Amazon that I just placed, will all be deleted. All the rows. Okay. So if you don't do anything, relational database following their strict rule on referential integrity, it would have not allow you. And that's maybe why people use this relational database when it comes to constraints, right? This is the added bonus for some people. And then people would choose to just stay put and then leave it like that. But if you're intentionally want to change it, you have two ways. And the first is cascade. And in this case, when your primary row is deleted, the foreign key row, all the order that has the same foreign key, those rows will also be deleted if you say delete cascade. A second option is on delete set null. What that would happen, you might not agree, but if the designer decided to use on delete set null, same type of logic over here, alter table, blah, 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 add foreign keys, blah, 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 reference to table, blah, blah, on delete set null, then basically on the order table, wherever the foreign keys has been used from that primary row, primary key row of the same table, meaning in this case, again, my orders, because my row in the primary table was about to be deleted, right? My primary key is about to be removed. Me is about to be removed from the customer table. Then all the order table that has foreign keys of my customer ID, all those row doesn't all get deleted. However, all those rows, the column of that foreign key will be set null. Okay? So the major two different here is just to clarify, cascade would impact the entire row to get deleted. Set null, the row doesn't get impacted except for the foreign key itself will be set null. Okay? Okay, so here's just more example that if you guys want to look at and then the syntax as well. Now, separately, another referential integrity is when, let's use the Amazon example again. When I'm as a customer, which means on their customer table, it may exist that I have a row there because I'm a customer. I have already placed a bunch of orders. So on the order table, there would be many rows which has my ID as the primary key on. Now, same example, same layer of background context. Differences here is today, whoever is the administrator, whether intentionally or unintentionally, is about to update my primary key, that column, that ID. Okay? They're about to change the ID of me as the customer. So let's say my primary key used to be in customer table as one, and then they're about to go and change it to 1000. Now, that is also another use case that the relational database is going to enforce the referential integrity. And by default behavior, again, it would be no updates because it will tell you that there are orders that has this foreign keys of me. It's not going to say that detail, but that's the reason that it will block it because there's already child foreign tables that has this foreign keys with this primary ID and that's already been in use. So it's going to block any action from taking place. But say it again, if you want to make it flexible and intentionally wants to change this default behavior, you can. And you can do it by two ways. On update cascade, on update set null. Now, slightly different on the on update cascade here compared to on delete cascade. Because on update cascade here will only change the value on your referencing table, which is your primary key ID, the foreign key ID. So it will match the new primary key value in the original table. Okay? So in this case, it's not going to update the entire row in your order table. And this comparably sounds like a somewhat logical thing to do. And it's probably a good solution, alternative, than do nothing at all. So on update cascade, if the primary keys would change, this would make sure that all the foreign keys will also be updated to the updated value of primary key. Now, you might ask me, what about set null? Yes, it is an option as well. And you could enforce that to be the action or behavior, whether it is making any sense or is by design, that is up to you. But you obviously have full uh, capability to change the default behavior to on update set null, meaning that if the primary keys has been updated to a different value in the original table, all the order now would be null on the foreign key number, not all null through the rows. Okay, just on the primary, on the foreign key value itself, that column. Okay, so it might sound odd to have this behavior, and I agree, but it is an option for you out there if you were to choose or design to change the behavior into on update set null instead of on update cascade or doing nothing at all because it's blocked by referential integrity. Okay, so basically what we just covered is that there is benefit when you use these constraints, and it's often used, uh, these constraints are often used because it automatically ensure that there's integrity within your schema and within your relationships, right? So when people use relational database, when you're normalizing, when you're using foreign keys, primary keys, you consider all good pros and cons. And normally these constraints might end up being useful. And, because of these constraints, a lot of these check and balance became automatic and by default, and which is a lot of people consider that into their design, right? But you definitely should know all the different type of integrity out there when you use them. And if in case you by design want to change the behavior by default, how would you be able to update that? And then today we gone over two of the scenario where it's on delete and on update, and then two type of behavior, on delete cascade or on delete set no. And similarly, on update cascade, on update set no. Any questions on constraints? Okay, so far so good. Now, we come back to refreshing and diving into keys. Uh, I believe I have gone over some of these, if not all of them. Let's look at some that Let's go over some. Primary key, foreign keys we went over before. Unikey is is similar to just making sure one of your column is always unique. Constraint, that's the biggest purpose out here with the unique keys. There's nothing more to that. Uh, we spoken about the combo keys, which is a just a subtype of primary key when the primary key is uh, has constitute of multiple columns, right? It has multiple column to combine into a key that we call that combo keys. Okay. Now, candidate keys and super keys. Now, candidate keys means all the candidate keys come with very little constraint. But the candidate keys is there for you to categorize columns that can potentially be a key by itself or in conjunction with another column. So, for example, in the combo keys, most of the time, each individual constituent within the combo keys are considered candidate keys. Okay. And now another example in customer table that we mentioned about in Amazon, it's very likely in a big company that they have their primary keys and very likely because normalizations and all that. So by design, they may have one unique columns for primary keys so that it's always had its own unique IDs and values. But as we know, names plus date of birth itself could be a candidate keys. Names plus, let's say, phone number, right, or email address, these also could be considered as primary key itself, but it might not be still as solid as just a random assign or incremented number as, you know, a newly created table, columns by and then given value randomly, right? But they are, however, unique enough and then could have been considered And those are the candidate keys. What are super keys? So super keys, I forgot if I go over this before, but it is your keys, it is your primary keys and combo keys plus another non-key attributes. Okay? It's basically short for superset keys. Now, if you remember in your statistic or math, superset, superset just means that you have a set. A superset is just the circle that embraces your set circle, which means that it has everything that your original smaller circle has, but it has some additional. So superset keys here, a super key here is namely superset keys, meaning that with your primary keys plus one to many other columns, that became a superset, and we call it superset keys. Okay? Index. Now, while index it itself is not a keys, and then it also not like it has constraints like primary keys or foreign keys. Index is brought to the topic with the keys here because it is used to be added to a column so that when you are querying using select query or store procedure or whatnot, it would, if it often gets filtered or joined or searched on this specific column with the blasting of the index, it would be more speedy to get your result, right? If a column by itself, not a primary key, but it still gets joined on or it gets filtered on in the where clause, or you get searched on in the select clause. If you give it an index, adding an index to that column, it can speed up the speed of your query performance. Okay? Now, there's two type of index. One is called cluster index. The other one is called non-cluster index. And we went over this at the beginning of semester. Primary keys are always cluster index. So primary keys are automatically indexed, right? So instead of a constraint that we didn't talk about what primary key gets, but in a hidden benefit, primary keys are always indexed. And it's indexed under clustered index. Okay. What cluster index means is that cluster index and primary keys are interchangeably synonyms, but because only primary key can be cluster index, and cluster index can only have primary keys. But cluster index just mean that not only is it indexed, it has already been been reshuffled and ordered based on this index of the entire table. Okay, so the table itself, when you're inserting new rows with the primary keys, it's always going to have some type of order, priorities, and all that, and then in its place and everything, and positioning. Okay, because primary keys is essentially, the ID. So there is already one order that has been set when you have primary keys, and that is thanks to cluster indexing. Okay, now non-cluster index is for those columns that you later on add index to, right? They are considered non-cluster index. Yes, they will have been added a unique hash table, so it speeds up your search filter or joining speed. Yes, it does do that, but it doesn't have this um, reshuffling, reorder just because you're adding an index to that column, right? It will still speed up, don't get me wrong, but it doesn't get to as invasive as primary key. So there you go. You have index, and under index, you have the cluster index and non-cluster index. Okay, let's take attendance right now. Take a minute and everybody take screenshot of the QR code and sign in. Oops. Okay, everybody got it?
Yeah.
Okay. All right. So continuing, if you are interested about indexing, please go to at the lesson or just Google indexing in SQL databases. But here, again, it's kind of reiterating, okay? Uh, when you have a column, and maybe when you're designing the database, you didn't realize it would be having so much join on them, uh, or you didn't realize that it would be a keyword, a hot columns to be querying or filtering on. You can always add index, which can help you increase the speed when you're querying it. Now, index is a good solution to increase the speed when querying, but obviously, um, balance is important, right? If you end up having every single column that you got in the database indexing in a non-cluster index, then that kind of defeat the purpose, right? Okay, here are the cluster and non-cluster kernel keys that I mentioned. And then here goes how you would create index. Okay. And you can create index on a single column, or if you feel like, for example, first name, last name, when someone querying looking up a person and trying to do matching on where clause, first name and last name normally come sort of back to back and side by side. So if that were for you to consider it beneficial to add both column a index, then this is how you would add an index to multi-column. Now, these are examples how you would add a index to non-key attributes because primary keys are automatically in cluster index. Okay, so with that key said, let's come back and review. Previously, we have this is by myself by me, all me. I created this table for your easy sort of memorizing purposes. And previously, I think that I created another table between difference of DDL and DML. And here goes that has slightly more than DDL and DMLs, but again, this is what the matrix of different type of statement that are very common in SQL that on the left side, it impacts solely on the structure and the schema design. On the right-hand side, it getting into the value and the actual data that has been stored within these schemas. Okay? So when you're um, creating the schema, the structure, the homes of your data, you use create table, create view. When you're actually putting in the furniture, putting in your items, putting in your belongings, you use insert into. Now, the second row is when you're trying to copy a table just with its structure, just with its design, you use create as. Okay? That way you get a copied, you get a copycat with no values in there. But you get exactly the same column, just different table name, along with primary keys and foreign keys when you do create as. Now, when you're selected into, then you're actually copying and pasting the value of your first table into the new table. Okay? Create at is just making a copy cat table structure. Select into is it's like inserting, it's like you're doing select and then after that an insert into to a different table. So it's just two in one. So that's why it's called select into. Okay, copying the data from table A to table 2. When you're changing the table structure, such as adding a column, adding a key, adding primary keys, adding foreign keys, adding index, use alter. When you're updating values of a column or the entire row, you use update. When you're trying to remove this table from the database or help from the uh, from the planet Earth, this entire housing for the data, you do drop. And this is slightly different from previous because when you drop, it means everything within it is going to get removed from the planet of Earth. So you're dropping the structure along with its data. When you do delete, there's two different type of delete. One is delete from table, and then you say where to make sure that it's filtered to just the row that you want to delete. And when you're deleting row, you're deleting the actual data, right? Or you can do delete all from table, which deletes everything from that table, all the data. However, if you do a select query afterwards, you will still be able to get result because the table itself still exists. Okay? Now, I spoke about this last week. Some of you are wondering, okay, if I have a large table and I kind of are scared to query it or join it or run a big query that I feel not so great about because it might slow down other people or whatever. Right now, you could think about using some paging mechanism by using top and offset when you're querying, in addition to like while loops, right? Using a while loop to like query just like subset of the table, etc. Or you can explore this keyword called explain, okay? And you can do explain followed by select query, or explain column, or explain blah, 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 right? I think each database may have its own sort of unique capacity of what explain can do, but most likely when you just explain followed by a table name or explain followed by a select query, it will give you a preview and most of the time include how many rows there are in this table or columns and or if there's an index on the columns, etc. So that give you a sense of the structural performance of the table or a specific columns for you using explain versus doing select and actually getting the values back by running the value on the table. Okay, so these are something that would be nice to get to know before tests. Like get to know each one of them, look for examples, or maybe do certain example on your own so that if it comes up on an exam, you know which one is to choose for certain problems. Okay, this is a sign off for your project. Okay, so when you are demoing and at some finish line, or maybe when you're starting to prototyping, when I meant prototyping, meaning like building sort of like a skeleton code and then start running and doing some type of integration test or regression tests, in addition to, not unit testing, but like after unit testing, but start doing these regressions or testings or like UAT test, you may want to have some dummy data in your table so that it will look in in it will look like real data and it may help you so that you don't have to enter all these values from scratch from your input field or your web. And one way, obviously, is to insert into statement, right? When you do insert into statement, you can do it by insert into one row, or you can actually do it in multiple rows at one time. Okay, so I just want to give you guys sort of this aha moment so that you're not stuck with manually creating all one by one, right? In addition to that, for your testing purposes, you could also import data from a spreadsheet that looks and has the same column, right, of your table. And you can import the data directly, right click on the table, and then you can do import for MySQL or Access or Microsoft. I know all of them can do. I'm sure that Postgres can do that too. Okay, so for your dummy data. Now, where would you get these data? You could either, for the dummy data, you can either use ChatGPT, and then they are very good at presenting very real life simulated data. Obviously, they're AI, so you can definitely do that, right? To This is totally fine to be efficient on creating dummy data. Now, there's a website called data.gov, I believe, data.gov. Let me see. It might be in my, okay, I didn't have it in my appendix, but data.gov is actually some public data of United States public government data. And then sometimes they have these CSV file or they have already some database type or text file that you could use if it's just to what you may need, like just names and address, and then some emails and blah, blah, and the public information. So that may be also somewhere like if you decided that you don't want to use AI and just want to get some like real data and just play around with that, or like, like those are normally the data that that either it's survey or like just public data, or from consensus. Okay, this is just side notes for the project. You could obviously use what we just learned. Use create table as. So that means that, you know, if you are thinking about maybe multiple different iterations of your database, and then you don't want to do this create writing up again over and over again, you can always do a create table as to copy over the table that you want. And then you can do a select into, so copy over old table to new table, right? Now, you should totally learn and look at example on how you would do this. And this is sometimes very helpful when it comes to really set up the test environment. So I highly recommend it. Now, if you are if you think of it, and then one step deeper would be, how do you make sure that if you're deleting data so that you're creating new sort of data sets for your test environment, to not waste time, you can always write up some query that include create table, select into, and all that stuff, and then drop table, all that stuff together, and have ChatGPT sort of like edit it for you, make sure it's error free and stuff like that, and then prompt it to do the steps that you're looking for. I think that that's for test environment to get your data and test dummy data ready and save times. I think that is something that's is a calculated move that I think is within the ethical realm. If it's just trying to for your testing purposes and getting data, I think these are manual tests that, in my opinion, would be silly to always do it manually row by row. All right. All the other update and alter, I will leave you guys. You need to definitely pay attention to these. And then again, all these things, all these slides afterwards are sort of elaborating on this table, and almost all of them, except for explain, has been covered. More than explain, and the copying has been covered multiple times. But these are, other than create, we just mentioned create as and select into. Uh, I think everything else we've covered live. And then so these are just examples. And I think that these examples are for you to, especially, you definitely need to scan through them. If you haven't already did on the textbook, you would need to make sure that you are familiar with them. You see, there's explain right here. You need to be familiar when you see them so that they're not stranger to you. You're knowing basic syntax, um, which would help with your exam. Last but not least, just kind of FYI, good to know is if you are log on, or if you are shadowing someone and you want to know what privilege you have, the first step is for you to know what kind of user, what level of capability you have. You first need to know what kind of user you are. So do select user or select system user to find out, are you a guest, or are you an admin, or are you a super admin? Once you find out you're a guest, you most likely just have re-access. If you have owner, admin access, you likely can do a lot of create, edit, delete, all those things that are more invasive to tables and databases. However, once you find out a user, you can always go to the user panel to see that each user, what role it has been added to. So to get a better sense of detail, sort of privilege each of the user that you log in as, what rows it have. Now, about rows and stuff, those are something that we will cover after the exam. So that means that this is something that's good to know, especially when you're practicing and coding it. It won't be on exam, but this is a good tip to know. When you're trying to find out, sometimes it's just running error. You cannot delete something, you cannot insert something, or you cannot drop a table or update a key, and you don't know why. And this is sometimes how the first step you will take to find out what roles do you have? What privilege do you get? Okay. Okay, well, I'm going to answer some question here as you may be able to see. What happens if the foreign key column in the order table has what? Has a Okay. So the first question here is what happened if a foreign key column in other table has not no constraint? So to repeat your questions, I'm assuming you're asking for a condition when there is a undelete or unupdate and then set null that you want to set it to so that when the primary keys are deleted and then you wanted to, and then you purposely said no, and then you want to know what happened. I will tell you this. I think that's a good question. I don't know the answer to that. I'm going to say that this never happened in real life for me to practice before. I think this is interesting. Like, I think this, if you're interested in find out, I think it's worth of investigating and then try it yourself. If I were to guess, because, you know, firstly, we do know that foreign keys doesn't have a no constraint. Primary keys does have. But if you enforce a no constraint to begin with, and then you also then want to set no, delete set no, I wonder if the options there's three possibility, and then I really don't know the answer to this. Never happened to me before. Obviously won't be on your exam, but I can think of three places that it might trigger some type of um divergent. And one of them might be when you're actually trying to update the integrity constraint to set no, maybe it's going to alert you. I find that possibility to be maybe on the 10%. Not likely because I don't know if they're going to actually look up on the foreign table when you're trying to change the behavior of a referential integrity. So that is 10%, but it could be. Second part is the actual whether or not when you're actually uh when it actually get deleted and then it's set no, that whether or not it might trigger another error and say that it has a no constraint so that it will block you or the that I have a feeling if I were to guess I would say that maybe 70% probability and the final 20% I'm going to leave it with it just happened so that it gets set no, even if you have a no constraint. But I feel like that is the possibility of that is 20%. So I am going to say I don't know the answer to that, but I will highly put my bets on restricted, no action. If because of all this constraint that you have set, and then the database actually, when a parameter getting deleted, it actually blocked from the whole delete because the whole first and second step.
Yeah, that's what I guess too. Thank you.
Yeah. Yeah. Okay. All right, we're gonna cover also, we just finished deck number six. We're gonna go over deck number seven, just because there's a lot more in there, and I was worried that we might not be able to finish. Okay, so, but we'll take a quick 5 minutes break.
I
Yes, is there a question?
I did have a question. What is the cutoff,
What
like the
is the
last class of
Mhm.
material that will be tested on for the exam?
Next class?
Okay.
It's not about the class.
All the
It's about,
material.
yes, the material is the next deck, which is the lecture seven.
Okay. Thank you.
Yeah. And then next week I want to finish lecture seven, and I also just want to hold on one second. I also want to have not only finish lecture seven, but finish exam review together. That's why today we're going to cover lecture seven as well, just in case so we won't not be able to finish.
Okay.
I have a question.
Yeah?
Um, so will the
What is
test
it?
have any, will the test have
I
any,
can't hear you. Can you speak louder?
hello?
Slightly louder. I cannot hear. Yeah?
Hi, can you hear me?
Yeah.
So will the test have any sort of like thing where we have to write down, um, like, like what our perspective is on like a question or like a short answer question, or is it just like true and false? You know, what is this table? Stuff like that.
Why would that change how you study?
I'm only asking because I want to prepare for the test as it is.
But how would that yes and no change your study?
I want to understand. I want to understand the structure of the test.
I already spoke about this. I already spoke about I spoke about the structure of the test on day one, actually. And I was going to actually speak about it next week again. So I'm not really sure, but I trying to understand is why would this change your study? If you understand the topic, why would that change?
Well, because maybe I would need to understand more information instead of, quickly going through information. I can't understand
I
everything.
would say the final answer from me would be you should understand because this is the college topic. And then if you want to pass and get good grade, you should understand. You shouldn't just scan it. You should do the work.
I understand that, but I'm saying how much information will we need to understand for the test? That's why I'm
Okay, I
asking this.
already spoke to you last week personally about what will be covered and what you need to study. And this is to everybody. And I already also mentioned that it will include multiple choice. There's going to be short answer, and I am having difficulty to understand what information you need from me. Like I don't know what is the level of details you need to know about an exam.
I think he's just
I'm,
curious about like
I'm curious. Yeah, exactly.
question
I don't really
types,
understand
I
why.
am not
just so he can.
okay, I don't think anybody you can speak on your behalf for your own self, but I'm going to be very clear that um, if there are something that you miss because you don't show up, you've missed class, the first person to ask is people in your class because they may have take notes or something like that. But If you have show up to class and you don't understand something, I could help you in trying to help you understand. But you also, everybody in this class must also put into effort to do the work. I can only do as much. All right. And then this is going to be the fourth time if you're interested in about learning about the exam review, that would happen next week. And since day one of this class, I have said it's going to be multiple choice plus short answers plus manual drawing of diagrams. Okay? With those, what with what I will not give any more informations about anything else about the exam other than what I just covered. And then the next week with the topic of reviews. With what I just said, anything I need to clarify with that?
No, you do not. Thank you.
Okay, we're gonna start on lecture 7. Okay, so let's see. All right, so we cover um, cover majority of fundamentals and sequels. And then so we are going to today intersect from SQL to slightly more intermediate of events understanding of relational database. Okay. And what I meant by that is by sharing with you some basic programming capability. What I mentioned by programming, meaning that these reiterative, conditional, uh, statement-like type of procedure or functions that SQL, relational data model, and relational database has. These are not necessarily uh, ones that maps to every single databases, but for majority MySQL, PostgreSQL, Oracle, Microsoft, they all have the same. Now, most of the NoSQL, first of all, they don't use uh, SQL as a querying language. And secondly, I do not believe that they have similar transactional sort of feature uh, with their buildup. So these are some of the most important ones that you should know about for your project, homework, and the exam. Okay, so before we talk about some of these important programming type within SQL, let's define some of the basic and refresh our knowledge a little bit. So there are SQL statements, there's SQL variables, and SQL parameters. So these shouldn't be too foreign to you, right? Um, if you think about programming language, right? There's variables. You will have uh, ways to initiate these variable, initiate an object, or define a class, right? Or run a function, right? So a statement here is a full-on executive procedure, include one to multiple functions. Okay, so for example, as you can see here with the select statements, and we have update statements. We have update statement where it has a set in there, right? So it itself could have multiple procedures, or it include multiple functions. Okay. Now, variables is when you're defining a container and you want to set values into it. So the most basic ones that we know is if you say for coding, if you say like int a equal to 3. So you're defining a as a variable, and then you set the value of a to 3. Now, similarly in SQL, you can you would have to declare a variable. After that, you can set that variable. Okay, so declare you would do at, and then give the name to value after declare, and tell it what data type. Then you say set, okay, this variable, and then follow because it's looking for integer. So in this case, this select value is returning count, which is the integer. Okay, so basically you declare the total counts and then you set the total count into the count star from the select value. Okay, so it's in two separate forms. Now, when I mentioned earlier, okay, you could declare or use this similar variable to store a table, okay? Given that you want to declare this variable as data type being table. Then you set at whatever equal to select star from blah blah. Basically, the entire information from a table, right? That is what I mentioned earlier on, what a 10 table could be initiated, okay? Using this at similar, just like a variable. So instead of storing just one single value, whether it's string or int, you could always store also a table, for example. And then later on, you will just reuse this at whatever name variable as a table. So you can select from it or query or join with it. Okay? Now, one new, I guess it's not new to developers, but new to people who are new to SQL and new words to our class is the parameters. When do we need parameters? When do we need parameters? When we have a procedure or a function that has user input values, right? That is depending on non-defined, not fixed, but rather user's input. Okay? So, for example, get procedure, create a procedure, get user, and with a user ID. So basically, in a nutshell, it's trying to get the informations about the user, right? So as you can see in the parameter, it's expecting an integer input, okay? With at user ID as the name of the variable, okay? Now, there's multiple types, okay, as you could declare the parameter. And there's in, out, or in and out, okay? We are going to look at this example in further detail later. All right, so the first thing we want to introduce today is SQL conditionals. So rather than having your code first evaluate true and false of a certain input statement, then command your SQL using a SQL statement to run certain query. Rather than doing that and sending two different SQL statements through the network, you could integrate SQL conditional and choose based on your conditions, what it evaluate to run the correct statement or variables of your choice. Namely, the examples are if or cases. So if comes with if, else if, else. Then these are the syntax reserved when you're writing conditional using if. When you're writing conditions using case, you do case given options within case by when. Okay? So case and when are paired. Case, when. If, then. Okay, let's look into this. For example, a SQL case statement. Case, when, and then what would happen after that? So select order number, and then you might want a different return a result set not being a column, or be either a evaluated, in this case, using case, or like a constant. So if you want to have the second result set return using case, what happened here is this case is used so order number first, and you want the second column to be known as quantity category. And based on the quantity value within the table, if it's more than 100, so that means that if this order number, this order number, if it has made 100, instead of returned 100, you want it to return in the newly created temporary column called quantity category, and you want it to return the level where it's either high, medium, or low, right? So if it's more than 100 of that order, you want it to be high. If it's more than 50, it's medium. Else, it's low. So I don't think I need to go further explaining how what case work, right? Just by syntax, you can tell that number one, it could be on the select clause. So that's first example. But the syntax is using case followed by when. And then after the condition, you do a then. And then follow, you can close using else as the very last condition with everything else. Basically, everything that is not your condition one to whichever many condition. And enclose it with else, meaning that everything that falls out of those conditions, it will evaluate into the else. And finally, you do an end. Okay, so this is the case syntax. Now, case could, this is still in select. So now this is an example in where clause. Okay, so instead of in select, this is an example where let me see, when material else equals 0 and equal to 1. Marital status equal to 1, then 1 equal, oh, then else equal to 0. Okay. So, and equal to 1. Sure, so one neural status equal to 7. S. Okay. So this is when it's evaluating in the where clause, where it look up on the marital status here, and then evaluating in this case, after the case happened to the end, the return result should be either 0 or 1, right? So if it's, hold on, case, is there a case when marital status equal to then 1, else case when marital status and equal to 0 equal to true when true, where is true? Okay, so it means that, okay, I understand. So basically it's doing this thing when marital status is single, for example, then it's going to evaluate to 1. So because this case, when it's single, evaluate to 1, 1 equal to 1, it's true. So basically what it's saying is that it only wants to return when marital status is equal to single quote S. Okay, this is slightly not, maybe not immediately simple for me to understand, but after reading it, so basically the case in here is there's maybe multiple type of marital status in these columns, and as long as it's S, then it want to evaluate to 1, right? And then so you can see that at the end, when they say the end keyword, that's when this case is going to evaluate its final result. And then using that final result, it could be either 1 or 0 to compare to 1 again, right? So this is doing where and then a comparing operations here. So if 1 equal to 1, it will means true, right? That means that return this row when miracle status was S, right? So that means if it was an S, it will be 0, then it will be false. So when it's false, this row will be skipped, which means that as long as it's not single, it will be skipped, right? So at the end, it will only return all the rows that has S in the marital status. As you can see, the result showing national ID number with every single result S. But long story short, this is just trying to show you that case could also be in where clause. And interesting, it could also be in order by clause. So in here, it's saying that if the city is null, then order by country, else always order by city. Okay? Right. Okay, so now it's the if statement that we all have been as we hear in conditional, we always know that if else is most common that pop into people's mind, I think. So as I mentioned before, if, else, and if, right? And then you still use then to evaluate after evaluation, right? So let's look at example here. Oh, okay. So this shows all the conditions that when you use if or when you use case, I guess, you essentially are evaluating a Boolean comparison. Like you're comparing and essentially want to get a truth and false, right? When you do conditionals. So these are all the ones that operations that we talked about before. And logical operation is not, no, is no, whatever. And then check whether or not is a no value or in, not in, etc. Um, all these are conditions that could shows up when you're using if conditions. Oh, wait, is there no example here? Oh, there's an example right here. Okay, so we'll just look at um, if the P operator, which seems like a variable here to me, if basically if there is a variable input variable was defined to be smaller sign, then do this query. If else if it's larger sign, then do this larger query and then do end if. Pretty simple. So it's evaluating whether or not P operator sign is smaller or equal. It doesn't have an else, so that it's only going to evaluate this smaller than larger than is going to not capture in the case of equal or smaller and equal. So just these two cases is going to evaluate and have the result. Okay. Now we'll talk about loops. Again, loops is in a condition because it also has an expression that it evaluates, right? Only that expression once is uh, dissatisfied, then the loop is going to be jumped out. So basically, if the expression is true, you're always staying within the loop and then do the statement within the loops until you're no longer, meaning you keep a counter or etc., or the status or the values of your table or the rows that you initially trying to evaluating at, many possibility those expressions are no longer valid, then you ended your looping and you jump out of the loops, right? So let's take a look at the example here of a procedure. Ignore the procedure for now, but let's just look at the while loop here. So while x is smaller than 5, then you'll do the concatenating string with it. And then every time you do concatenation, you do x equal to x plus 1, right? So initially x was just 1. So while it got to this while loop, I feel like I'm doing a very computer science 101, but I'm assuming you guys are all understand, so I'm just going to go very fast. So x initially was 1. So it's going to come in here the first time, and the second time will be 2, will go in again, 3 go in again, 4 again, 5 again. So it's going to come into this loop 5 times, right? And then the string will be string 1. So I'm assuming string is concatenate a string x1. So it will be a string x and then a space, quote unquote. So a string initially is single quoted. Okay, so basically it's going to be in the end, it's going to be like triple quoted x1, single quote, and then single quote x2, single quote, single quote x3, etc., all the way to x5 until you end the while loop. Okay, infinite loop, I don't think I need to explain further. Everybody should know here is that let's say if you don't have this counter and then you always keep x equal to 1, so it's going to just keep on running nonstop because you don't have a expression that what allows it to change the expression and then getting out of the loop and help it terminate. That's called an infinite loop. Okay, so we will, let's see. We will be ending after this slide. I'm just going to give a brief introduction. Okay, ACID, which stand for atomicity, consistency, isolation, durability. I think this is the fifth time we came back. And as I mentioned, we are always going to come back here about these four characters many, many times since day one. But to introduce transactions and to review ACID, acid over here, we should pay attention to how many times I mentioned that relational database, aka SQL database, also known as transaction database, because it has this nature by default that come by default with relational database that you could run a transaction. Within transactions, they could be multiple statement, even procedures. And within the premise of the transaction, by default, relational database allow you to say rollback if any of the statement within the transaction before the rollback had failed at any place. Or you can say commit, meaning that get to the point where as long as all of them run, you want your database to be committed with the change so that rollback cannot roll it back. If you roll back after committing, you cannot have it roll back to before these changes happen, right? So transaction just means almost like a code block, but you rather want all to happen or nothing happen at all is basically the concept of transaction. Okay. And because of atomicity, consistency, isolation, and durability that relational database come with, the feature of these four, it comes with, it allowed the transaction to be always running with high confidence level and returning data without dirty read or race conditions. And then making sure that data are not going to mix when you are updating a data from a table that's not doing any join to another table or isolated from another table. The other table is not going to have corruptions or anything just because a remote database, a remote table is being updated. And finally, the durability is making sure that once committed code has been set, you're not going to see old data or past history shows up. It could be in the log, but it would always return when you query the right, which is the latest committed data. So we will be getting into more detail on transaction in addition to store procedure, as well as our final topic that's going to be covered in an exam, which is database and system design. So it's not just about designing a database, it's about how modern day world today design their front end, back end, database, and how do each of these module in the system or design speak to each other. Okay? So I'll leave it up here. If you have any question, you can stay behind. Otherwise, It's 7 o'clock. You're free to leave.
Um,
Yeah, no. Where's the guard?
Yes.
I have a question. Uh,
It would have
could
to
you
be some.
uh I was trying to follow along with the lecture, but it says I can't access it. I was wondering if you could make it public so I can review it later.
Which one?
The lecture you were just going over, lecture 7.
I will be publishing it. I haven't. I always do. Yeah.
Okay, thank you.